Permutations. And we're going to be looking at permutations without repetition. Okay. So here's an example. Julia, Emma, and Talia have entered another permutation contest where 10 gummy bears are awarded to the first winner and 5 gummy bears are awarded to the second winner. That's how you can tell it's a permutation, because there's a difference between first place and second place. Okay, so the order matters. The position matters. Permutation, position. Okay, 2 names are chosen without replacement. A name will be drawn. That person is given 10 gummy bears. The name is not put back into the hat. Another name is chosen, and that person is then given 5 gummy bears. Okay, that is a gummy bear, in case you're wondering. All right, so Emma, Talia, and Julia. Okay, so possible winners. All right, could you get Emma and Emma? No. Okay, so that can't happen. Emma and Talia. Emma could win first prize, Talia gets second prize. Okay, yeah, that can happen. Emma, then Julia. Sure, that can happen. What about Talia, then Emma? Sure. Okay. What about Talia and Talia? No, because the name isn't put back, so we'll take that out. What about Talia, then Julia? Sure. How about Julia, then Emma? Yep. And that's different than Emma and Julia, right? Because Emma gets the 15 gummy bears, gets the 10 gummy bears, and Julia just gets the 5. Okay? So here, Julia gets the 10 and Emma gets the 5, so that's a difference. So that's what makes it a permutation. Okay? Julia, then Talia. Why not? And Julia, then Julia. No, that can't happen because her name wasn't put in, so we'll remove that. Okay? So in this case, we're talking about, yes, permutation, and order does matter. Okay, who is chosen first and who is chosen second matters. Okay, so in the first place, how many possibilities do we have? Okay, there is like 1, 2, 3. Okay, so there's 3 possibilities for the first choice. Okay, 1, 2, 3, like that. Okay, for the second choice, how many possibilities do you have? Well, let's say we chose Julia, right? You could only get like 2. You could only have Emma, then Talia, so 2. All right, does that make sense? So 3 times 2. All right, let's look at another example. Permutations. Permutations, order matters. Okay, remember permutations. Emma, Caroline, Talia, Julia, Andrea, and Leslie have entered another permutation contest where 15 gummy bears are awarded to the first person, 10 gummy bears are awarded to the second winner, and 5 gummy bears are awarded to the third winner. Names are not replaced after each draw. Okay, so if you came in first, you can't come in second and third. Okay, so here we go. So that's Emma, Caroline, Talia, Julia, Andrea, and Leslie. Okay, so in first place, all right, how many choices do we have? 2, 3, 4, 5, 6. We have 6 possibilities for the first place. Okay, so let's say Leslie won the first one. Okay, so now we no longer have 6 people who we can draw from. So Leslie's name has been drawn, she's been given and has already eaten her 15 gummy bears. How many people are left? Well, only 5. 1, 2, 3, 4, 5. Okay, and that is it. Okay, and then for third place, there's only 4. 1, 2, 3, 4. And there we go. Okay, so in the first place, it's 6 people. In the second, for the second place, we have 5 people left to choose from. And for the third place, we have 4 people left to choose from. So 6 times 5 times 4. Okay, there is a bit of a trick to this, okay? So, yeah, that's 6 times 5 times 4 is 120. Okay, and there's a shortcut for this. I know it doesn't seem like a shortcut at first, but it is a shortcut. All right. Now, 6 times 5 times 4 times 3 times 2 times 1, that's something called 6 factorial. Let me just show you that on the calculator. Okay, and it's a neat little button on the calculator. So 6, it's this thing with a little exclamation point. You click on it, factorial. So that's 6 times 5 times 4 times 3 times 2 times 1 is 520, right? But we just want to do 6 times 5 times 4. Okay, so what we can do to get rid of the 3 times 2 times 1 is divide by 3 factorial, right? Like that. Because we're only interested in the 6 times 5 times 4. We're not interested in the 3 times 2 times 1. So we're going to divide by 3 times 2 times 1. Okay? So our shortcut is we're going to write 6 factorial over 3 factorial. Okay? All right. Now, So the 6 factorial is our n, right? So our n factorial. And then how do we get the 3 factorial? So what we do is we do the 6 take away, well, how many choices did we have? 3. So 6 take away 3, that gives us our 3 factorial. Okay, and this is our formula. Don't worry about this so much. We're not gonna worry about this. We're more worried about like the 6 times 5 times 4. Okay, this is more important. Okay, so this is a permutation without replacement. All right, who is chosen first or second matters. That's why it's a permutation. Okay, just remember that R is our number of winners in this case. Okay, we only have 3 winners, and N is our number of people that we're choosing from. Right, so R is the number of restricted choices. So restricted R. Okay, and N is the number of objects to choose from.